Hi everyone. Today I want to talk about uncertainty, dark data, and the ethics of system design. Most modern technical systems are designed to produce certainty. You open an interface and you see a number, a classification, a prediction, a risk score. It looks resolved and objective and final. But technically, most of these systems do not produce certainty. They produce probability distributions. They approximate. They optimize loss functions over historical data. A classification is usually the highest value in a probability vector. A risk score is a statistical estimate conditioned on past correlations. A recommendation is the result of similarity in embedding space. These outputs are not truths. They are structured guesses, and yet the interface presents them as conclusions. When probabilities collapse into a single number, uncertainty disappears from view. But it does not disappear from the system. It becomes hidden. Now consider dark data. Every model requires feature selection. Engineers choose what variables are measurable. Institutions define what is relevant. Datasets are constructed within constraints. Anything that cannot be encoded, standardized, or scaled is often excluded. That exclusion, though, is not neutral. It defines the limits of a system's perception. Dark data is everything the model cannot see: context, exception, structural inequality, cultural nuance, temporal instability, human complexity. When dark data is excluded, the model learns from a partial representation of reality. It optimizes on what is measurable, not necessarily what is meaningful. Here is where the ethical problem emerges. If a system trains on incomplete data and hides its uncertainty, it does not simply make mistakes. It institutionalizes them. Consider credit scoring systems. If certain communities have historically faced economic instability, the training data reflects that instability. The model learns correlations. It assigns higher risk scores. Institutions respond by restricting access to credit. Access becomes limited, opportunity narrows, and instability continues. The model did not understand context. It only optimized correlation. The outcome appears objective, but the process amplifies historical imbalance. So this is not intelligence. This is simply feedback reinforcement. The same dynamic appears in hiring filters. If past hiring decisions favored certain profiles, the data set encodes that pattern. The model then learns similarity to historical hires. It ranks accordingly, but what was excluded from the data? That would be potential, nonlinear career paths, contextual growth, and unconventional backgrounds. Those become dark data. The system does not merely overlook diversity. It penalizes deviation from historical patterns. And because uncertainty is hidden, the penalty appears justified. When systems erase diversity from their training representation, they fail to learn from it. Learning requires exposure to variation. If variation is filtered out as noise, the model narrows its worldview. Over time, optimization pressure forces sameness. Edge cases are treated as anomalies. Anomalies are treated as risk, and risk becomes exclusion. At scale, exclusion becomes structural. This is where ethics enters. A system that hides uncertainty while acting on incomplete data does not simply simplify reality. It redistributes power. When a probabilistic estimate is treated as a verdict, individuals are judged by abstractions. And when abstractions are shaped by partial data, the system begins to punish humans for not fitting its model. So instead of adapting to human diversity, the system demands that humans adapt to it. That inversion is ethically significant. Technology should accommodate human complexity, not compress it into compliance. So what would it mean to design differently? Technically, it could mean exposing confidence intervals instead of single scores, indicating data sparsity, surfacing which features influence the prediction, acknowledging what the model was not trained to recognize, allowing institutional override when contextual information contradicts the model. These are not cosmetic changes. They are epistemic commitments. They acknowledge the inference is not certainty. They restore space for judgment. They prevent overconfidence from turning into institutional rigidity. When uncertainty is visible, systems remain tools. When uncertainty is hidden, systems begin to act like authorities. The difference between those two states defines whether technology supports human agency or quietly filters and reshapes it. Dark data reminds us that every model is incomplete. Uncertainty reminds us that the probability is not truth. And ethics reminds us that incomplete systems acting with confidence can cause real harm. If we want systems that learn, truly learn from human diversity, we must stop treating variation as error. We must design architectures that can admit limits. Uncertainty is not a weakness. It is an ethical requirement. So I hope that that was interesting, and I hope that you learned something new today. And thank you for listening. Take care for now.